Hi there, I did my video project on Gibbs free energy and cellular metabolism. Gibbs free energy is very important to understand within the cell, especially for cellular metabolism. It's going to use the equation of delta G equals delta G under standard conditions plus the gas constant times temperature times the natural log of the reaction quotient. And you're going to use this equation because the conditions of the cell are non-standard. And it's normally non-standard because if you remember, standard conditions are 1 atmosphere, 25 degrees Celsius, 1 molar concentration. And a lot of times the reactants aren't going to have 1 molar concentration. And so that's what makes it non-standard. But Gibbs free energy can perform work in the cell with a uniform temperature and pressure. The metabolic process is non-spontaneous. This is going to make it endergonic because it requires an input of energy for the reaction to occur, meaning it absorbs free energy from the surroundings. So this is going to give you a positive delta G for the system. And an example of this for cellular metabolism would be light being the input of energy for photosynthesis, as photosynthesis is a metabolic process. What is cellular metabolism? It's a process that synthesizes organic material. That material for photosynthesis, for example, would be water and carbon dioxide, and it's going to synthesize that into oxygen and sugar. And it does this by breaking the bonds in the reactants. And if you remember, that requires energy. So that's where free energy first comes into the metabolic process. And reversible reactions are exergonic one way and endergonic the other. So an example of this would be photosynthesis as the endergonic reaction requiring energy, requiring that ATP, while cellular respiration, the reverse of that, is exergonic and it releases free energy. Cellular metabolism and Gibbs free energy. You can see how Gibbs free energy works in photosynthesis as a metabolic process. Again, light is the source of input of energy, and that's what makes the delta G positive. Once that E energy is absorbed by photosystem 1 and 2, it's processed into ATP and NADPH, which from there on in the metabolic process is going to represent the free energy, as ATP and NADPH are super high in potential chemical energy, which is the same thing as free energy. They're interchangeable. And this is given from the catabolic processes of the reverse of cellular metabolism, which is cellular respiration. ATP and cellular metabolism. ATP gives cellular metabolism energy by releasing free energy. Again, think back to that concept that free energy is chemical potential energy. So ATP has high chemical potential energy, and then it can be used or used as that input of energy into an endergonic reaction like cellular metabolism. And then it will be lowered in that potential energy at the end of the reaction. Enzymes, ATP, and free energy. Enzymes harness this energy of ATP to drive chemical reactions. Enzymes themselves are non-spontaneous reactions, while they use ATP to catalyze spontaneous reactions, but they're normally super slow. So an example of this is hydrolysis of sucrose to glucose and fructose, because that is a spontaneous process that will occur without outside influences. However, it would take years to be completed. So sucrase, the enzyme, speeds this up to seconds. To understand enzymes, we also have to understand activation energy, which is also called free energy of activation. If you can't tell, free energy is in this as well. Again, drawing back to the fact that bonds require energy to break, What activation energy is, it's the initial investment of energy to start the reaction so bonds can break. Enzymes use free energy from ATP to lower this energy of activation, which does not change the overall free energy of the reaction. The way this actually works in cellular metabolism is the enzyme will attach to the substrate, which will then undergo synthesis and form an enzyme substrate complex. This process actually stabilizes the transition state of the substrate, which in turn increases the number of successful reactions, which in turn increases the rate of metabolism. The last stage of cellular metabolism is forming the new products. Remember, for photosynthesis, it has the reactants, but it also has the products of the oxygen and the sugar. And if you remember, forming bonds actually releases free energy. So that delta G that you put into breaking the bonds will be re-released when the products are made. And that's why the overall delta G of the reaction is constant, or not constant, but it's going to be the end in the same. And again, cellular metabolism is reversible with cellular respiration. So when cellular metabolism is complete, cellular respiration is going to take place, and it's going to be the opposite. So rather than using that free energy, it's going to provide that free energy for cellular metabolism to use once that cycle is complete. And that's it. Thank you for listening.